The top is not a problem. Anyone? Any suggestions?
U1 plus X 3/4.
And hope for the best. Hope that du will not be a problem. And if the problem is a number, that's never a problem. A factor can always be made up. So can anyone give us the differential of this function? Again, we're not integrating right now. I know that that's the confusing part.
3x to the 3/4 x to the negative 1/4
3/4 minus 1, negative 1/4.
times dx.
That's it. So 3/4 and subtract from 3/4 1, and this is negative 1/4 dx. Great job. Good. So now let me double check, because it looks a little bit weird. Did I copy correctly? This was 1/2 and this is 3/4. Yeah, I did copy correctly. Good. Okay. Okay. So we have, that's why I'm thinking for a second. So this will become du equals 3/4, basically, the 4th root of x dx. So I'm thinking for a second if this is the right substitution. Sometimes we may start on a wrong path. That's very possible. So let me think about this. Because what I expect is du to be this, but it's not. So this does not seem to be the right substitution, to me anyway. So what if, so this is the 4th root of x to the 3rd. So what we really need, we need to get that to the square root of x. So I'm thinking for a second if I need to rationalize first. Because this is not helping me. And I can't get rid of that, the square root of x. So this is the 4th root. Just I need one more thing to check here. So if I denote the square root of x by u, what will happen? Du will be 1/2 the square root of x dx. And what have I accomplished with that? I would rationalize. So the top will be u 1 plus x to 3/4. This is not giving us what we want. What if I have u equals the 4th root of x? Du equals 1/, so this is x to 1/4. 1/4 x to negative 3/4 dx. And that the top will be u squared, the denominator. What do I do with the denominator? That would be 1 plus u to the 3rd. If I use this. yeah, the denominator doesn't help us. So let u be the fourth root of x. Okay. So if I denote just the fourth root of x, so what I have, this function is basically the square root of x over 1 plus the fourth root of x to the third. Okay, dx. I may have to use two substitutions on the way. Okay, so for now, I'm going to say that u equals, it's a very interesting problem. Thank you. So u is the fourth root of x. Then du, so this is the same with u to 1/4. I'm sorry, x to 1/4. X to 1/4. So then du will be 1/4 x to 1/4 minus 1, which is negative 3/4, times dx. So then du equals 1 over 4, the fourth root of x to the third dx. Okay. The numerator is not going to be a problem because the numerator will be u squared. The denominator will be 1 plus this to the third, u to the third. And now, how do I make up the dx? So in this case, I have to explain to you that most of, in all these examples that we looked at, it was very easy to identify the du and the dx. Not on this problem, however. So on this problem, I have to solve for dx. So dx, multiply both sides by this. So dx will be 4, the fourth root of x to the third du. So dx will be 4. The fourth root of x to the third is basically u to the third du. This problem should not be here because this uses, but we'll finish it up. Oh, okay. I ran out of time, but this function will be changed like this. The integral from x to 1/2 is this squared. Because if you square this, you get the square root of x. So this will be u squared. The denominator is what I just said, 1 plus u cubed. But dx has to be solved, so this will be times 4 u to the third and du. And this problem uses partial fraction decomposition. I have to change the limits of integration from 1. So this, the fourth root of 1 is 1, and 16, the fourth root of 16 is 2. So you're free to go, but I have to finish it now since I started it. So the integral becomes from here. So 4 is outside, the integral from 1 to 2, from u to the fifth over u to the third plus 1 du. And the partial fraction decomposition is a method that is taught in Calc 2. And we basically have to present, so u to the third, we have to factor u to the third into u plus 1, u squared minus u plus 1, and change this into a over u plus 1. It's a whole theory, b plus c, bx plus c over bu plus c over u squared minus u plus 1. So I have to determine the constants a, b, and c and decompose this integral into 3 integrals. This one and this one. So I don't see any other shortcut that just to denote, because if I denote this, then I can make up this. Maybe I can if I just solve for dx. Maybe I'm making it too difficult. So let me also try that using the substitution we started with. So what will this be? When I plug in 1, the fourth root of 1 is 1. 1 plus 1, this will be 2. And when I plug in 16, the fourth root of 16 is 2. 2 to the third is 8. 8 plus 1 is 9. Okay. So the denominator is u. The numerator, yeah, that's the problem. I can't get, so I have u minus 1 equals the fourth root of x to the third. And how do I get x squared from this? That's the problem. Maybe if I continue with dx, let me see. Maybe dx will save it. It's possible that dx will save it. So dx is 4, the fourth root of x divided by 3 du. So what I did, I multiply both sides by 4 and I divide by 3. The fourth root is in the denominator, so it goes 4. Yes. So that will be dx. So this, I'm having difficulties, the fourth root, okay, with this, look at that. This times this will give me that. Oh, that's what it is. Okay, I see it now. So 4/3 du. Okay. Yeah, interesting, very interesting, because when we multiply this by this, the square root by the fourth root, we get the fourth root of x times, so the fourth root of x times the square root of x. This is x to 1/4 times x to 1/2. So when I add these two, 1/4 to 1/2, I get 3/4. Nice trick. Nice trick. Okay, I see it now. Well, I didn't see it at first. That's another way. That's a partial fraction decomposition. We'll get the same answer. But the beauty here is that we can continue with this substitution. The denominator is u. That's okay. Dx is indeed this. 4/3 times the fourth root of x times du. And now the fourth root of x times the square root of x is x to 3/4, which is u minus 1. I did not expect that. So now let's finish it and then we'll check. So this is, oops, 4/3 is outside. Now we separate u over u is 1 minus 1 over u du from 2 to 9. Okay, so 4/3. And of course, u minus natural log of, I don't have to write the absolute value because I have 2 to 9, from 2 to 9. So let me just double check my limits of integration. So where was I? Just to make sure that when x is 1, yes, this is 2, 16, the fourth of 16 is 2, 2 to the third is 8, 8 plus 1 is 9, correct. Okay, so then I have 4/3, and this is 9 minus natural log 9, but minus 2 and plus natural log 2. So I'm getting 4/3, 9 minus 2 is 7, and minus natural log 9 plus natural log 2. Thank you so much for being patient. I'm so sorry you don't have to. I just, once I started, I can't leave it. Okay, where am I? So again, careful how you plug it in. It's not that easy to plug in these functions in this form. Good. So where is my original? My original was from 1 to 16. Because I'm also curious now. 16, okay? And that's x. And what was it? Initial. So the square root of x, and divide by, in parentheses, careful, 1 plus. This was an interesting problem. Okay, in parentheses, 3/4, careful. And close the parenthesis for the denominator. So we have the square root of x over 1 plus x to 3/4 dx. So I press enter and it was going to give me whatever. And now I have to plug in my numbers. 4/3, in parentheses 4/3, close, multiplied by 7 minus natural log 9. Where are you, natural log 9? Close, don't forget. Plus natural log 2, close, and close again, because all this has to be multiplied by 4/3. And if I don't get the same thing, then I have to start from scratch and pull my hair. But there was no need. This was not an obvious problem at all. Not at all. The tricky part was, one more time, where is my function? The tricky part was here to observe and note that this multiplied by what dx gives will give us an x to the 3/4. Who would have guessed? It would have been it was difficult to guess that. So yeah, that was very interesting. Thank you for choosing that.